Excuse me, your voice is not audible. Presenter, please, you are not audible.
Good evening, everyone. I'm at MCA. I welcome you all for the second day of the session organized by Computer Engineering, Computer Application Department of Kongu Engineering College. Today we are going to discuss about data preprocessing in machine learning. Resource person for today's session is going to be Dr. C.S. Kanimoy Shelby. She has more than 20 years of teaching experience and 10 years of experience in research. She has published more than 50 papers in international journals and presented more than 25 papers in national and international conferences and authored one book. Her area of interest is machine learning and deep learning. She is carrying out two funded projects, one for DST and another for ISS currently. At the time, she is working as professor in Computer Science and Engineering Department of Kongu Engineering College. We welcome you, ma'am. Now I request all the participants, please kindly mute your system and disable your video. Now I have a session to ma'am. We welcome you, ma'am. Thank you. Ma'am, I think your voice is not audible, ma'am. Ma'am, please unmute yourself. Present.
Done it. Sorry. Okay. So let me start from the first slide. So first let me explain what is AI, ML and DL briefly, and then we'll go on to data pre-processing, some theoretical aspects, and then we'll move on to hands-on with data pre-processing using Python. I hope you have already had an introduction yesterday about machine learning. Today I'm going to briefly explain what it is, and then we'll move on to data pre-processing. Am I audible now, sir? Can anyone Am I audible?
Yes, ma'am, you are audible.
Yes. Okay, then thank you. So artificial intelligence are the broader spectrum in which it enables the machines to think like human and behave like human. Tesla's autonomous car is an example for artificial intelligence. I can say that. And the chess playing computer, it is another best example, which is based on artificial intelligence. Next, we have machine learning. So machine learning nowadays it is booming a lot, and in variety of applications we are using it. So it is a subset of AI technique which uses the mathematical concepts and it learns from data automatically. So that is what machine learning is. So AI and machine learning usually, when you go for AI, then machine learning comes in automatically. You'll implement some ML methods in and you'll make the AI systems. So the next is deep learning. Deep learning is a subset of ML, which is especially used with larger data sets. So that is the difference between AI, ML and DL. So this is what I want to say. Okay, deep learning is deep learning also it needs high-end machine. You cannot directly apply deep learning for all data sets, and so you need high-end machines for big amounts of data. You need to use high-end machines. GPU like machines you have to use. GPU machines we have to use. So what you can say is machine learning and deep learning is a way of achieving AI. Okay. So these are the steps in machine learning. So the first step in suppose you want to build a machine learning system, then the first step is to collect the appropriate data. You need to collect the relevant data. Okay. So gathering data from different sources which are required for carrying out a certain application. And then we have to prepare the data. Preparation means you have to, actually the real world data will not be, will not be usable directly. You have to clean it. It may be it may be inconsistent, it may be inaccurate, it may contain some missing values. So what you need to do is you need to clean it properly. So when you do without when you apply machine learning without cleaning the data, you'll not get accurate results, right? So the first step is data collection, and the second most important step is data preparation. Okay, you need to perform that is you need to apply some pre-processing technique so that the data can be cleaned and it can be used for building the model. Okay. The third step is building the ML model. So usually we'll build the ML model based on the problem statement. So you'll go for regression model sometimes. If suppose you have to build a model based on numerical data. Suppose I want to predict the rainfall of tomorrow or day after tomorrow, you have to go for regression. Suppose I want to predict stock price of a particular company, then I have to go for regression. So based on the data and the problem statement, you have to decide on which technique you have to use. So the regression will be used for numerical prediction. Classification will usually do it for categorizing your data. Categorizing your data means suppose I want to know whether a person has some disease or not. Whether he's having a particular disease or not, then you have to classify. You have to use the classification techniques. There are a variety of classification techniques available. You have to use an appropriate one. The next thing is clustering. So it is grouping up of the similar items together, right? So based on similarity, we'll group certain data. So suppose you might have a group of customers' data. You can group them based on their credit rating. So whether they are all good credit rating customer or average credit rating customer and so on, right? So we can group them based on the similarity. So the difference between classification and clustering is that classification requires it is a supervised technique which needs the mapping between input and output. You need to have some input data along with what is it the output of that particular data. So whereas in clustering you need not have mapping between the input and output. So you'll be having only the input data. You have to group them based on its similarity. So it is called unsupervised learning. So anomaly deduction is another technique which is used to find the outliers. So outliers means the data which does not comply with the normal data. We call it as anomaly data, and that needs to be detected. A particular example of this anomaly deduction is credit card fraud detection. It's best application using this anomaly deduction technique. Recommendation is another technique. So recommendation, which means a product recommendation. So you might have come across several product recommendations, movie recommendations and all, reviews and all. And so based on the rating and everything, you can decide upon, you can build a recommendation system and which will help you guide the customers. So these are all the modeling techniques usually we apply. After building the modeling, you'll have model evaluation. So in model evaluation, usually we'll choose any one of this model, right? So based on the data set, the type of the data set, and based on the problem statement, you'll be choosing any one of this technique, and you will be using some methods for classification has hundreds of methods, clustering has many methods. So it will choose any one of the method in those techniques and will build the model. And after building the model, you have to verify whether the model is working properly or not. That is, how to validate the model with some data. So that is called test data. Usually the data which is used for building the model, we call it as training data. The data which is used for testing our model, we call it as validating the model, we call it as test data. So training data is used for building your model, and the testing data is to validate your model. Okay, so that's all about machine learning. Now we'll go in deep into data pre-processing. So data pre-processing, as I told, the raw data is not in understandable format. What you need to do is, the real world data may have incomplete, inconsistent and inaccurate data. Some are missing and some are not in proper format. So what you have to do is, you have to prepare the data for further processing. Then only you'll be getting the model a better one. So usually there are two types of data: numerical data and categorical data. So the numerical data can be categorized into discrete and continuous. So as you know, the data in numbers, we call it as numeric usually. Sometimes the number of students in a class is an example of discrete data. It is discrete, right? Yes. Am I audible? Do you have any doubts, sir? Yes. Yes. Okay. So if you have any questions, then unmute your mic and ask, or otherwise post your questions in chat window. I'll answer after my session is over. Right? Okay. Okay. So there are the second type of data is categorical data. It can be categorized into nominal, ordinal, and dichotomous. Nominal is the variables which have which is like a string. We can anything in a string format. You can call it as nominal. Gender is an example. Ordinal, gender or otherwise age. Sorry, not age. Nominal is like your profession. It can be nominal data. Ordinal data is of another type. Here the values are in the values of this kind of variable will be in ordered format. So like the grades of the student, O grade, A plus grade, A grade. So they should be in they have some meaning, and they have some proper ordering, right? So those variables we call it as ordinal variables. Dichotomous is like your binary variable, like it's like boolean or binary, what you can say. You can say that. So there are two values for a dichotomous data. Okay, so these are all the general types. Okay, now let us come to the missing values concept. So the main thing, important thing in data pre-processing is to identify the missing values and to handle the missing values, right? Suppose you're asked to collect the applications of all your students and to perform some ML model and to build an ML model, then you may find that there are some data that are missing, right? The student may have not entered it properly. Some data may not be in a proper format. That is, some for instead of a numerical value, there may be some a non-numerical value and so on. What you have to do is first you have to identify all the missing values, right? So you have to handle it properly, and then you have to perform some transformation in order to make your data set standardized, a standardized one. Okay, so this is an example in which you can see that there are so many missing values, right? So in many columns there are missing values, right? So these missing values have to be treated, and so I'm going to explain in this in context with the Pandas library. That is, I'm going to link this concept with the hands-on session. So how do you handle missing values using Python is that first you have to check for missing values using a method called isNull. So it will check whether there is a missing value or not. If there is a missing value, it will give the answer true. Otherwise, it will be entered as false. Okay. And then you have to replace the missing values. Find the missing value using isNull, and you have to replace the missing values using these functions, right? Fill NA. That is, you have to fill the missing values using fill NA. So you can replace them. So fill NA means you can fill with some values, right? The missing data can be filled with some value, right? Sometimes if it is a numerical one, then you can fill it with 0, right? So replace with mean. Replace can be done like if some of the columns are not here, you can say age. In age field, one of the data is missing. What you can do is you can find the mean of the remaining data, and you can fill this missing data with the mean or median. Okay, you can take anything like that. If suppose you want to fill a missing value which is of categorical type, then what you can do is you can go with mode. Okay, you can find the mode of that particular column, categorical column, and you can fill with mode value, right? So usually these are all the ways you can fill the numerical and non-numerical data, the missing values of numerical and non-numerical data. And you have another method called interpolate. Okay, so it uses several methods and it finds the nearby values and it will fill it with nearby values. Drop and drop NA are the two methods which will drop the particular rows. Okay, suppose any field, any row is having missing values, that rows can be removed or a particular column can be removed. Okay, so this is another technique. Okay, so this is how you have to handle missing values. So the next is next technique in pre-processing is scaling or normalization. What you can say, both you can say. So here is an example of scaling. Suppose you have here we have two attributes, right? The two important attributes. One is salary and the next one is year of experience. Okay, so both are in different scales, right? Salary is in thousands and year of experience in like it is up to 15, right? So the maximum value is only 15. Okay, so here suppose if you use these two data for building your model, then salary can take higher priority over this attribute year of experience. So what you have to do is have to standardize, or you have to normalize your data so that both will be in the same range. So that is one may not have higher priority than the other, right? Both will be considered equally important. So that is the purpose of using scaling. Okay, so here there are two types of scaling we are using. One is min-max scaling and another one is standard scaling. Okay, so in min-max scaling, here this min-max scaling will transform the data so that the values of that of that particular feature will be in specific range. Like it may be between 0 to 1 or 10 to 20, according to the value which we are specifying, according to the range which we are specifying, it will be scaled, right? So this is min-max scaling. So the original data will be like this. This will differentiate how the original data and how would be the scaled data, right? So the original data will be in some range, but the scaled data will be in 0 to 1, right? So you can have this kind of normalization. You can perform this kind of normalization so that one attribute may not have a higher priority over the other attribute. So this is an example of min-max scaling. Suppose for a data set, we have to this is the formula, like x minus min divided by max minus min. So here the min represents the minimum value in the minimum value of that particular feature, right? The minimum value of that particular feature, and max represents the maximum value of that particular feature, right? Suppose you want to change, you want to scale a value x, then you have to calculate like this. So the value x, suppose I want to scale 18.8, 18.8, I want to normalize with the observed values, like min is equal to minimum is minus 10 and maximum is 30. Then it can be calculated like this. Okay, so any value can be normalized between 0 to 1, right? So here the value will be after normalizing, after scaling, the value is 0.72, right? So the new value of the normalized value for 18.8 is 0.72, right? This is how it is calculated. So the next method, as I told in normalization, is standardization, standard scaling, right? So here this standard scaling is used to arrange the data in standard normal distribution. Okay, so it transforms the data attributes with Gaussian distribution with mean value of 0 and S, standard deviation of 1, right? So you can see within this figure, the data is centered around the mean value, and the values are it's not skewed, right? You can see that it is not skewed, right? After normalization, the data is not skewed, whereas in the original data it is in the skewed format, right? So that is what the difference, right? So this is called standard scaling. So this is the formula for changing the one data into a standard value. Okay, so this is also called as z-score normalization, right? Z-score normalization is z is equal to x minus mu by sigma. So this is the formula which is used. X represents the data to be standardized, and mu represents the mean of the entire column, and sigma represents your variance, standard deviation, right? Sigma represents the standard deviation. Okay. So now let us see another data pre-processing approach, data dimensionality reduction. So which is used mainly in image applications and all, image processing applications and all. So here what it can do is it converts the high dimensional data into lower dimensional one. Okay, but it not change the specific information of that particular variable, right? So we have two dimensionality reduction techniques. One is feature selection and another one is feature extraction. Feature selection extracts, it uses three approaches: filter, wrapper, and embedded approach. So usually the filter approach filters the most relevant variables from the original data, and it after filtering, it uses the filtered data for building your model, like the classification model, and then you will be getting result. Sometimes we'll be using a wrapper model. A wrapper model in the sense, while building the classification model itself, it identifies, it extracts the relevant variable, and it it wraps around, like the classification and feature selection, it combines together, and it is using it, right? So the next one is feature extraction technique. It is used to reduce the dimensional data to a lower dimensional phase. Okay, we can do feature selection or feature extraction. Okay, so usually the dimensionality is reduced, but the original information is not lost. So this is how the dimensionality reduction is done. So there are many dimensionality reduction techniques are available. I think today's session will not, we have only 1 hour left, I think. So if possible, we'll explain the dimensionality reduction, and we'll do some hands-on in that. I think we can do up to the previous one. Okay, filling up the missing values and normalization and all, I'll do and explain. And dimensionality reduction, if time permits, I'll do it, right? So these are all the dimensionality reduction techniques: backward feature elimination, forward feature construction, low variance filter threshold, and principal component analysis. These are the vast topics. I think if And if I explain all these things, backward feature elimination is that here the attributes which are first you will be considering every attributes and you will be removing the attributes which are irrelevant first. Okay, so we are removing the attributes one by one. So while during the data selection process, we'll have every attributes in our packet, and then we'll be removing one by one if based on its insignificance, right? So that is backward feature elimination. There are several measures used for that for eliminating, for calculating the importance or significance of the feature, and based on that you'll be eliminating it. So forward feature construction is, so initially we'll have empty in our hand. So what we'll do is, we'll be getting one by one, right? So we'll be getting the most important attribute first, and then the next most important attribute, and so on. Like you will be you'll be using, you'll be constructing the features, and we'll be adding the features like. So the next one is low variance filter and principal component analysis. These two mainly are used in image processing techniques. Okay. So what we'll be doing is, here based on a filter. Excuse me. Hello. Am I audible?
No, ma'am. Yes, ma'am. Yes, ma'am.
Yes. Okay.
No, ma'am.
Okay. Okay. So now we'll see, these two are mainly used in image processing applications, right? So first, let me go to Google Colab, and we'll do the hands-on with data pre-processing. Okay. Sorry. Okay, I think in the yesterday's session itself, you have introduced with Colab, right? Yeah. So what I'm going to do today for this hands-on is, so type colab.research.google.com in your web browser and click on new notebook. Okay. I think I have my data sets in another. Yeah, I have already downloaded it. Yes. I think I'll go for this. So I have my data set in that, in this drive. Okay. Okay. So before that, I think I have two more slides about Pandas. I think yesterday itself you have introduced with Pandas Library. Pandas is an open source Python library, and it's used for data manipulation and analysis, right? So it is derived from the word panel data. It helps in performing the performing the pre-processing activities like load the data, preparing the data, manipulating, and to build your model and to analyze your model. It will be very much helpful. So usually the Pandas deals with three data structures. Series, data frame, and panel are the three types of data structures. So series means it is one-dimensional data. It is labeled and homogeneous. Here, it is not data structure used in pandas is data frame. It is two-dimensional, labeled, size mutable, heterogeneous typed columns, right? So you can have heterogeneous types. Yes,
Excuse me,
ma'am.
ma'am.
Yes.
Hello, ma'am. Your screen is not audible, ma'am.
Screen is not visible. Yeah,
Not
sorry.
visible.
Yes, yes. I'll go for that, ma'am.
Okay, thank you.
Please stop sharing with the. It is there actually, but it is not. Okay, I'll do it once again.
Now it is visible, ma'am.
Oh, I have stopped sharing now. Yeah, I don't know why. Is it visible now?
No, ma'am.
Whether my PPT is not visible, right? Okay.
No, ma'am.
Yes, ma'am.
Not visible.
No, ma'am. Not visible.
Okay. Yes, yes, yes. I'll do it. I'll do it once again. Okay. Okay. I think let me explain here itself. So pandas. Okay. I'll have this. So I can write a text here itself. You have. You can create. You can use a series, right? So I'm going to use, or I can use.
Ma'am, your present screen is
Not visible.
ma'am.
Not visible, ma'am. Yes. Okay.
Yes, ma'am.
Okay, ma'am. Okay. Present now.
Start. Present.
Yes, ma'am. Yeah. Is it visible now?
Yes, ma'am. Yes.
Yes, ma'am. It is visible.
Yes. Yes. Here pandas comes with 3 data structures. Series, data frame, and panel, right? So first we'll see how to create a pandas series. This will help you to create your own data set, right? So while with the use of these data structures, we can create your own data set, or you can extract some data set, you can load some data, existing data set, and you can do some pre-processing, right? So pandas is used for that purpose, for data manipulation and for data modeling, preparation and all. We'll be using this pandas. So now we'll see how to create a series, right? So usually what we'll be doing, we'll be importing that particular library, and I'll be giving an alias name. Pandas is the library. You have to import that, and you have to give an alias name as PD. So you can give any alias name. Now, so you can, how do you create? So PD dot, I have to call the series. Okay. So within the series, I have to define the values, right? So the values may be, so it is of homogeneous type. You have to remember that series is of homogeneous type. You have to give only the homogeneous data, right? So you can give any string, like I'll be giving some string names of okay. So this is your let me explain. So what is the constructor of series? Pandas dot series of. So these are all the things you can give. First, you can give data, and you can give index. Okay, index can also be specified, and you can give the type, data type, and whether you want to have a copy of that or not, right? So like call by value or call by reference, the two ways you can use. Here we have other names for that, shadow copy, like shadow copy, I think some other memory copy, right? So you have two types of copies here. So whether you can create a copy and you can work on that, or you can work, right? So usually the data is the thing we have to give. That is, we need to give the data compulsorily. So here I'm using pd dot series, the data I have given, right? So index is right. So that is why I'm giving only the data here. So I think, yeah, I have some problem in this. Okay. So now, so I'm running this. Here you see we did not pass any index. First time it will take time. After that it will not take much time. Okay, yeah. Here we did not pass any index, but the index is like, it is assigned from 0 to 0, 1, 2, etc. like that, right? So the index is assigned from 0. So then, okay. So now how will you assign an index? We'll see how to assign an index. The second attribute is index, right? So we'll see how to assign an index. So I have a problem in, so I'll use my okay, yeah, I'm getting it now. Same thing. So now what I'm going to do is I'm going to define an index, right? So the index can be defined using index keyword. So anything can be given. So if suppose you have not specified any index, then it will be from 0. So you can specify your own index like A, B, C, or anything you can specify, right? So I can specify like this. 3 values I need to specify integers, right? So this is your data and this is your index. Okay. So now we'll see. Sorry, I have missed it. It's very slow. Why, I don't know. I'm not getting it. The mouse is not working. It's very slow. Oh yes, it's very slow. I don't know why. Yes. So this is the bracket I have to use. And I have to close the brackets also. So I'm specifying two lists, right? So one is for data and another one is for index. I think you might be knowing how to specify a list and all, right? Okay. So this is how, here you can see the indices are A, B, C, right? So now, so what you can do is you can give like that also. Like so now we'll see. Instead of the values, you can specify. So I can specify like this: list 1 is equal to this. I can specify it as a separate list. Next one is equal to and then I can give x equal to pd.series of list 1 comma index 1. So in this way also you can specify. So you can extract one list and store it in a variable, and then you can use it for creating your data frame. This is one way of creating a data frame of homogeneous type. Yeah, I have not displayed it. I have not displayed it, so it is not being displayed. Yes, the same thing can be achieved like this. So now we'll see. So how to create a data frame, right? So how to create a data frame? Okay, and then we'll move on to load your data, and we'll move on to the data pre-processing now. So first we'll let me see how. Let me show you how to create data sets on our own. So here, what you can do is, so you can create like the same thing. I can use it here. The list 1. And I can create data frame using pd.data frame, right? So frame of. So for this, what I have to do is the list 1. So I have to display the df, then only it will be displayed, right? I have df. So display df now. Okay, so this will display. Okay, so you can, here you can see that the indexes are automatically assigned starting from 0, and the column name is as 0, right? So suppose you want to give name for a column, then I can give like this, you have an option called columns, yeah. Using that, columns, I can specify the column name. So suppose so the list of columns I want to specify. So it should be in square brackets. So I'm going to define the column name as names. Okay. Sorry, this is not here. I'm sorry. I have not. List 1 comma names equal columns equal to names, right? Okay. Yeah, there are 2 commas. Okay, so here you can see the column name, right? So in this way you can create your own data frames, right? So panel is other type, which using that you can create, that is you can have in data frame you can have two-dimensional data, right? So the two-dimensional data can be created like we can have a name and age. You can have another another attribute, age is equal to, I can give like this, like 3 I can give. Okay, so these two list, like this is name and this is your age, this can be combined, that is it can be merged together, that is it can be horizontally merged, and you can have one row, right? We can build rows, right? So for that you have to use zip command. Okay, so list 1 comma list 2 I cannot give. Here I have to give only one attribute, right? You have to remember that the data has to be given here. The data consists of two columns here. One is the name and another one is list 1, and another list is age. So what you have to do is you have to zip these two lists together, and then you have to give a single name, right? So list of this function, zip function, you have to use in order to zip these two lists together. List 1 comma age. Okay. Okay. So there are two columns here. So one is names and another one is age. We can give age here. Okay. So shall we check? Yes, there are two columns, names and age. And there are 3 rows, right? 3 rows, 2 columns and 3 rows. We are building two-dimensional data now. So this is how you can create a data frames. Now we'll see how to load the existing data set into your Google Colab and do some pre-processing on it, right? So we can create using many methods. So now we'll see how to load the data, right? So I have 2 data sets in my drive. I'll share it to you. Sorry. Ma'am, Payudi ma'am, shall I share it?
Yes, ma'am.
Or I'll show you demo itself. Are the participants are working side by side, or
We will ask for participants, ma'am.
yes? Okay, ma'am. I'll share
We
it
are
now, or
working, ma'am,
I'll share it
seriously.
later. Are they working? Are they working side by side?
Yes, ma'am.
Okay,
Yes,
then
ma'am.
I'll do it. Yes. Okay. Doesn't drive. My net is getting too slow. It's taking too much of time. Yes. Okay. These 2 data sets I'm going to share you. I'll share it one by one. Okay. The second one also I'll be sharing.
Ma'am, you share
Okay.
data set also, ma'am.
Yes, ma'am. Yes, I'm sharing the data set only now.
Okay.
I'm sharing the data set only. Yes,
Okay.
it is on my drive, so I have shared it. Yes. So usually it is in Google. You can download it from download directly online. But I have downloaded it already, so I have saved it in my drive. Now I shared it. So now we'll see how to load your data, right? So in Google Colab, you have to upload your data from the drive, and then so first you have to write code for that. So first download your data and save it in your drive, local drive. So the people who are working along with me, please download your data from the Google, from this shared link and save it in your local drive. Okay. So this is the thing you have to do. Okay. So and then now, this is one way of doing it. Okay, especially in working with Google Colab, the first one maybe you can use the online link directly, and you can specify the URL, and with that URL you can directly download it. If your net connection is sufficient enough, data is sufficient enough, then you can fast enough, then you can do that. Otherwise, you download first and then save it in your drive, local drive, and then use it. Okay. So now how I'm showing how to download it from sorry, how to first you have to upload your data into Google Colab, and then how to use it, right? So these are the two steps to upload your data from Google from your local drive to Google Colab. So from this is so from import file from files I have to use Google Colab. So files is a library, and from that I am using Google.colab, and what I am going to call is I'm going to call an upload function, right? First I have to upload my data set into Google Colab. So for that, so this will return a variable. Okay. So let me explain first. Okay, I'll upload the Titanic first, right? And I'll explain it with Titanic data set.
over here.
So from files, I have to call the function called upload, right? So this will prompt you to choose a file from the local drive. I have already downloaded and stored it in my local drive. So first let me open it. So choose files and go through your browse button and select the local path and select the file and give open. So you have to wait till 100% is done. Now this file is uploaded in Google Colab. In your drive, it will be loaded. So it will be uploaded. Now what I have to do is how to import this particular data into your data frame. Okay, so especially for working with two-dimensional data, the data frame will be supporting, and for heterogeneous type, you'll have to use data frame, right? So what I'll be doing is, so here these are all the codes. Have to give to import the data into a data frame. Okay, so suppose I'm going to use Titanic DF. I can give the name. I have to store it. I want to store it in Titanic data frame. This is in CSV format. You might have seen that it is in CSV format. So you have to use, I think yesterday itself madam told about how to use the CSV Excel files and all, read CSV, read Excel and all. So I have used it directly now. So read CSV, I'm going to read the CSV file, and I'm going to import the data which is uploaded already in the Google Colab, right? So for that, what I have to do is, so it is in up_ file, right? So that file I have to upload it. So, and I have to convert it. That is, this I have to do it. First thing is up_ file. I have to upload with the file name .csv. Okay. So what is the file name I have used, and how and what name it is uploaded, that I have to give it here. So in what name it is uploaded? It is uploaded using Titanic, right? So I have to give Titanic.csv, right? So this, sorry, that I have stored already. And store it in up.file, right? Yeah. Yes, it's correct. Titanic.csv. Okay. So I have to get it from up_file, the file name which is to be given as that file name, Titanic.csv. Okay. Okay, that's it. So I have, yeah. So now we'll display this. We'll see whether it is uploaded properly or not. So usually I'll work with Anaconda framework. So in this it is different, read_CSV, and then you can give file name directly, right? So this is something different. First you have to import your data. You have to upload your data into Google Colab, and then you have to import it into the data frame, right? So it is a two-step process. In Google Colab, it is a two-step process. Wherein your local drives, suppose you are working in Jupyter and all, directly by specifying the local drive path directly, right? So this is one difference between your local machine and this Google Colab. So we already uploaded. Yeah. What is that? I have an error. Is it correct? The file name is correct or it is not correct? I don't know. I'll check. In what name it is uploaded? Maybe what is the error? Actually, go to the last line. You'll see what is that error. Expected file path name. What object type? Right? Yeah. So then we'll check whether the file name is correct. It is titanic.csv only. Titanic.csv, right? Yes, I have already uploaded. Yeah, and that's why I have forgotten. Like it will not be uploaded directly. It gives you an error, right? Like it should be an bytes object, right? So go to the last line. You can got an error, the YS error, right? It should be converted into bytes array, and then it should be imported, right? So for that, I have to use io dot bytes io. Okay. I have to convert this using this. Okay, that's why I have imported IO. I imported IO, but I have I wanted to do it step by step, right? So that's why I have imported IO, right? So now this will be imported, right? Now you can see all the yeah, it is a Titanic data set. It's a famous data set. And so that accident, Titanic accident, a film by name Titanic. Okay, so the same thing, same data set, which is in Gaggle. I have extracted and I'm loading it in the Google Colab now. Okay, so now, so we'll see here. There are so many rows. How many rows? 891 rows and 12 columns. And there are some NaN values. NaN values here are missing values, right? So you can see in cabin, you have some NaN values, right? And there are 12 columns. So there may be 891 rows. There may be many NaN values. That is missing values. These NaN refers to are missing values. Like, so the first, in the first row, we have the column names. This is the headings, and these are all the rows, right? So this NaN values are the missing values. Those have to be identified and it has to be treated suitably so that only I can build an accurate model, right? So we'll now I'll show you how to find the NaN values, okay? And which column you have the NaN values and how to deal with. Using isNull, I can able to identify the NaN values, right? So which column I'm having this NaN values. I think you all might be knowing how to access this DF data frame, right? So the data frame, so in which name I'm storing it? I'm storing it in Titanic_TF, right? So I'm using that name. So I can use either LOC or ILOC in order to locate because ILOC means I have to specify the rows and columns. Okay, the start and end index of rows and the start and end index of column I can specify, right? So the start index starting from 0 to 10, I'm going to display. The number of rows I'm going to display is 0 to 10, and the columns I want to display is from 0 to 4. Okay, so okay, so only 10 rows starting from 0 to 9 I'm getting it. I think you might be aware of all these things. In yesterday's session itself I think you have gone through all these things, right? And there are three columns, 0 to 4, like there are 4 columns, 0, 1, 2, 3. First, second, and third and fourth columns. Fourth columns are only displayed. 10 rows and fourth columns. This is the start and end index of rows, and this is the start and end index of your column, right? So I think you might be aware of all these things. Suppose I want to read only this column. I want to select only certain columns. Okay, then what I can do, I can underscore df from the data frame. Sorry, using ILOC. It is ILOC is used for indexing, all right? Numerical index to specify numerical to extract your data from numerical using numerical index. Then I have to use ILOC, right? So suppose I want to use only the first 100 rows in my data and only the columns. Only the columns which I need, right? Suppose I need only. So the columns are indexed one by one. Starting from 0, it is indexed, right? The passenger ID is 1. I think you will be knowing about how to. That dot info will give you the information about the entire structure of your data set, right? So Titanic df underscore first we'll see that info. Okay. Okay, you have you have this many rows and columns. Okay. I think why it is not showing. And suppose I want to know only about this important columns alone. Suppose I have to know about, I want to know about, these are all the columns, right? So what I can do is I can select the first column is age, right? The second column is cabin, and then name I want to display, right? So 0 is the first index, age I want to fetch, and then cabin I want to fetch, that is 1, the column index is 1, and name, so that is 2, 3, 4. Okay, 0, 1, and 4 I want to fetch. Then what I have to give, so otherwise I can give the name itself, right? So what I have to do is ILOC of only the 100 records I want to fetch. So 0 to 100, comma, the columns 0, comma, 1, comma, 4. Right? I think it is correct. Yeah. Let me check. It is age, sorry, 0 is passenger ID, right? Okay. Survived and 6, right? Survived and 6. Okay. So these 3 columns I have fetched, right? But it is not in, I think it is not in, the columns are displayed according to their alphabetical order, I think. Yeah. Now it is the 0th column is passenger ID and the first column is survived and the 4th column is 6. So only these 3 columns are displayed and the records are selected up to 100 only. Okay, there are 100 rows and 3 columns, right? So this is how the rows can be selected. Only the required data you can have and you can select only the required data. So now we'll see how to select okay, how to find the not null values, right? Okay, so here you have to use the is null is your thing. Okay, first let me show how to drop and then we'll go for that. Dynamic underscore df. First, suppose I want to drop only, suppose the first three columns. Let me show you with this. Okay, I want to drop only dot drop function. You have to use drop function. Okay, I want to drop only the 3 rows. Okay, maybe that sorry, 3 rows means 1 comma 2 comma 3. I have to give, right? So which will drop 3 rows, the first 3 rows. Okay, we can see the result now. Okay, so you can see, yeah, the rows, 0th rows is there. The 1, 2, 3 indexed rows are not there, right? You can see. So you can drop certain rows by specifying the index of the row numbers, rows, right? So this is one way to drop the not required rows. Okay, so sometimes you may not be requiring, it may have many null values. The row contains only it is an inaccurate data. Then you can, what you can do, incomplete data, then you can drop using drop command, right? So this is one way of dropping it, right? Or otherwise you can do it like this. Df drop. I want to, suppose I want to drop the cabin. Okay, so one particular column I want to drop. Then what I can do is I have to specify the column name. It has to show no. Drop cabin. I have not specified within quotation. Yeah, it will show you now. Cabin. And what is the thing you have to specify here is I will get an error. Okay, so what is that error? You see, cabin not found in access, right? So there are 2 values for an access parameter. Okay, so in drop you have to use access. In many of the functions of pandas, you have to use access command. Okay, so access 1 means it represents row. Access 0 means it represents row. That need not be specified. By default it is access equal to 0. If suppose that's why I'm not using access parameter in the previous case, right? Because I have dropped 3 rows. Okay, by default access is 0, so I have not specified access as 0 there. But now I'm going to drop the columns, right? So I have to give access equal to 1. So now the access value is okay. The cabin is dropped and it is displayed. Okay. So this change is not permanent. So to make this change as permanent one, actually even display it once again, what you'll be getting is, okay, so when I get the result, when I check the result, cabin should not be there, right? But it is there. You can see here cabin is there. Okay, so when you execute this, when you execute after dropping, immediately the changes reflected, but after execution it is not changed permanently. So what you have to do is, while executing, I have to do like this, like in place equal to true. Okay, I have to give in place, then only the change will be permanent. Okay, so there is a parameter called in place, so that I have to set it as true, then only the change will be permanent. Okay, okay. So I don't want to make the change permanent because the cabin has several null values, so I don't want to remove it now, right? So otherwise, in order to make the change permanent, you have to give another parameter along with this access. Okay, here you have to give in place equal to true, right? So true. This you have to give. Okay. So this will make the permanent change in the data frame. So usually it'll do this. So now I am not doing it because I want to perform some pre-processing on that particular thing because I have some coding. I have some null values found in that particular column. So I want to keep it. Okay. Okay. So now we'll see how to find the null values. Now I am going to find the null values using isNull parameter. Okay. So isNull method. So this isNull will give you your true or false value, right? So the whichever value is missing will be mentioned as true. Whichever value is there, for whichever the columns which are having values, it is replaced as false, right? So if there is any missing value, then it is shown as true, right? isNull is shown as true. Okay, so I think you might be seeing here this cabin has more null values, right? So I wanted to do have the summary of the null values. I can do this by using sum. Okay. So I am running out of time. Okay. Titanic _df. Yeah.
Good evening, madam.
Yes, ma'am. Yes, sir.
So, madam, just my link is a problem, so that I missed that part. Madam, regarding axis, you have told that axis 0 means we represent that row part.
Which one, sir?
Axis means the before command where you are using the axis.
Yes, sir.
If axis equal to
when you give axis equal to 1, it represents column. Yeah, axis equal to 1 means it represents your column. Axis 0 means it represents your rows. Okay, by default axis equal to 0. So to specify your rows, you need not specify it. Yes, sir. Yes.
Madam, if whenever we are using that drop command and write axis equal to 1 means it will be drop the first column.
No, not the first column. The column which you have mentioned. So you can see here.
Okay.
Yeah. The column axis equal to 1 means it represents the column, right? If suppose I have not given anything, it will refers to the row, right? So there is no row indexed as cabin. Suppose yes, there is any row indexed as cabin, then that will be deleted. So here in this case, it represents that particular column, right? So here if axis equal to 0, then it represents the rows. So there are two options only, 0 or 1. You cannot give more than that. Axis equal to 0 means it represents your rows, 1 means it represents your column. There are two values for this parameter. Is it clear, sir?
Okay. Yes, ma'am. Yes, ma'am. Thank you, ma'am. Thank you, ma'am.
Okay. Okay. So this is your, so you can find the sum of null values, right? So there are so many null values. Okay. So in, I think these are all the null values. In these columns, these are all the null values. In age, you have 177 null values. In cabin, you have 687 null values. And in embarked, you have 2 null values, right? So this is the summary of null values. In order to get a summary, you have to use a function called sum. Okay. Okay. Suppose I want to drop this. So because the cabin has 687 null values, it may not be useful selecting this particular attribute. So what I can do is, so in my, okay, let me do one thing. I am storing it in another data frame. The result I am storing it in another data frame. Drop this particular column, right? So which particular column? That is cabin. It is having more null values, right? 687 null values. So this is a column. So what I have to do? Drop is a function. In that, the column name you have to specify as a parameter, and whether I am going to mention the row or column. So I am going to mention the column. So I have to display this. So this column will be deleted, will be removed. Yeah, you can see here after age you have cabin, it is not displayed now, right? Okay, so this column is removed now. So this is one way of treating the missing value. The thing which is the column which is having most null values can be removed directly, and you can work with the remaining columns. One way. Okay, so the another way is that you have another missing value here, missing column. A column which is having more missing value, that is age. So age is a numerical attribute. You can see here, age is a numerical attribute, right? Age is a numerical attribute. So how I can treat it? I can treat it using, like I can find a median and I can replace, right? So first I can find the, so from this, this age, I'll find the mean or median, right? I'll find the median. Usually you use median. Okay. So find the median of this particular. Yes, it is 28. So now what you can do is, you can replace this. You can use the replace command. Okay. So Titanic. I think it is, I'm running out of time. I'm a little bit slow, I think. Yeah. Age. Okay. This particular variable can be replaced whenever you find a null value. Okay, you have to replace it with the median age, right? So you have to use a replace command, replace function here. The replace function takes 2 arguments. Okay, so first, what is to be found? That is NaN values you have to found. So it should be represented as np.nan, right? So the missing values are usually represented with NaN. And this value have to be replaced with which value? This median value, right? So you have to find np.nan and that should be replaced with this median. Okay. So this is how you have to replace. Okay. I think I have missed something. What is that error? NP is not defined, right? So it's a numpy. Okay, it is from this package, it is referred, numpy package. Okay, so now you can see all the values. There are 167 missing values, right? Before that. So all these values are now that is filled with the median value. That is, instead of the null value, the median value is filled. So you can check it out using eSum method. Okay, so Titanic df, sorry, Titanic underscore df dot sum. Is null dot sum, right? How many is null values are there? I have to find out, and that summary I need, right? So I have to call these two methods. So now you can see there are no missing values in age. Sorry, again it shows the missing values. Yeah, what I have missed it here is I have not used in place equal to true, right? So when this in place equal to true, then it will be okay. So what I can do is df, and I'll display df now. Sorry. I'll execute df dot is null of sum. Okay, so there is no missing value because I have replaced all the age values, all the age value, all the missing age values with the median of age, right? So this is how it can be replaced, right? So when otherwise I can give in place equal to true, so that it will be a permanent change. It is going to be a permanent change. Okay, so suppose I want to remove the values which are okay. Okay, mparked can also be removed, or what I can do here is, okay, so I can write or otherwise I can do one thing, I can show you. Okay, I'm not going to do anything with now. So what I can do is I can show you in place equal to true. Okay. Okay. I type in place equal to true. Okay. Or otherwise I'll show you another thing. Yeah, drop NA. Entire row. I want to drop the NA. That is the entire row. So in that case, what I can do is I can drop the row and I can show you. Titanic underscore df dot drop NA. Okay. So this method will drop the entire row. Okay. Even if a simple column, one column is missing, even if a single column is missing, it will drop the entire row, right? So initially, I think you might be knowing there are 851 rows. Now we'll check how many rows are there. In place equal to true, right? So this will make the permanent change. In place equal to true means it will make a permanent change. Otherwise, it will not make a change. This will be temporarily available. The changes are not permanent. So now we'll check Titanic underscore df dot is null of sum. Okay. Yes. Now, yeah. Now you can see every row which is having a single, every column which is having a single missing value is checked and it is deleted, right? It is dropped. So that's why there are no missing values here. Okay, this is this one. I will reduce the number of rows, but it removes all the all the rows which is having missing values, right? So what I can check here is, so now we can display Titanic. The structure, I think it's not showing here. Let's show. Or info. Sorry, it is info. Okay, there are 183 entries. Okay, so you can see here. So instead of, there are only 183 entries. You can see here, there are how many entries are there? That is 8. Instead of 851 rows, 853 rows, we have only 183 rows now. Okay. So this is how the null values are removed, right? So the missing values are handled. Okay. So now that is, you can drop the rows, or you can drop a particular column, or you can treat the missing value by using that is, if suppose if it is a numerical data, then you can find the median of that, and you can replace that particular column with the median value, the missing values with the median value. Or what you can do is, if it is a categorical data, then you can calculate the mode, and you can replace the particular column missing value with mode. Okay, if it is a categorical data. So these are the ways. Or you can drop the entire rows even if you found a single column value is missing, right? So this is how you can treat the missing values, right? So there are several methods like interpolation and all for treating the missing values. I'll tell you one method, and you can explore more on that later. So here, I think DF is already, I have stored DF, right? So I'll give, suppose, yeah, DF already have interpolate. Okay. So this is a method to find the nearby values and replaces it with the nearby values, right? So the method, here there are so many methods you can use. Okay, for interpolation methods you can use. One method is that it's linear. Okay, so how it is going to work is method equal to linear, and you can specify the direction. I think it will work. Yeah. Yes. So here DF contains only the age is replaced by the nearby values, right? Suppose I am doing it with a forward direction. This is for only for age. For the entire data set also, I can do it by specifying the entire data frame. That is Titanic underscore DF. So in that, what I can do is, I can limit the direction. So if suppose I limit the direction as forward or backward, so the values for the nearby values in the forward direction will only be used for replacing the missing value. So if you specify backward, then the values after that, the value for replacing the missing value, right? So I think you might be knowing what is forward and what is backward, right? So it specifies. So I can give backward or forward. Okay, so the direction can also be specified. So it will consider. Yeah, I cannot show. Yeah. So instead of here, the missing values, the nearby missing values are replaced. Sorry, the missing values are replaced with the nearby values. While replacing it, it considers the data from backward, right? So that is, it takes the data of the remaining data after the missing data, and it finds the nearby value, and it replaces it. So in case of forward, it will do it. That is in the reverse direction, right? So the upper values will only be considered for finding the nearest value, and the missing values are replaced in that way. Okay, so these are all several methods. We have many methods. I think we are running out of time. I think you can explore much better with this introduction, right? So with this 1 hour, I can able to show you only this much, and there are so many things that are available. So you can you can explore more using this, so whatever I am telling, I think it will be useful, and you can able to explore much better. Okay. Do you have any questions? I'll take few questions from audience and we'll close. Anybody? Yes, I have not gone through your chat window since I have hands-on. I would not do it. Okay. Okay, I'll share my hands-on along with my PPT with Pangudi ma'am. So, thank you. I assume that there is no question. Do you have any questions? Audience, please ask me.
Madam?
I'm ready. Yes, sir.
Madam, actually, how to calculate the p-value from that data set, madam?
Sir, you are not audible, sir. Please be louder, sir.
Madam, that p-value, how we can evaluate the p-value from the particular column, madam?
P-value, you are asking about p-value. Nearby value, sir. It is not p-value, it is nearby value. I am talking about nearby values. Nearby values in the sense, yeah. Suppose you have 25 and 28. So in the forward direction, you have 25. So above the missing value, you have 25. And below the missing value, you have 28 as the age value. Then in case of forward direction, 25 will be taken. In case of backward direction, 28 will be replaced.
Ma'am?
So that is what I am telling, right? So yes, sir. Yes, ma'am.
Ma'am, can I fill
Yes.
zero values, sorry ma'am, mean value instead of zero, ma'am?
Yes, ma'am. So I have shown you how to fill with median value, right? So you can
Yes,
fill with mean value also.
Okay,
There are
thank
so
you,
many
ma'am.
methods. Yes, ma'am. In case of numerical data, you can go for statistical measures like mean, median, mode, mean, median. Otherwise, in case of categorical data, you can find the mode and you can replace the missing value with mode value.
I'm asking about zero, ma'am. Instead of zero, can I fill mean or median values, ma'am?
Yes, ma'am. You can use replace method.
Okay.
In replace, instead of NaN, you give 0.
Okay.
And the value which is going to be replaced can be given as a second parameter that you can give. Yes,
Yeah,
ma'am.
thank you.
Replace is like our normal find and replace. So the first parameter is the parameter which you want to replace. So first you have to find all the missing, all the values with 0, and then that has to be replaced with the median or mean, anything you want.
Can you?
Yes.
Hello.
Yes, ma'am.
Hello. In case of ordinal, how can we handle the missing data, ma'am? In case of ordinals.
Yes, ma'am. In case of ordinal data, usually it should be handled like numerical value. So first you have to find out suppose I have 5 grades of our student, like S, A, B, C, D.
Okay.
Like so in that case, S should be replaced with 0, A should be replaced with 1, and B should be replaced with 2 and 3. First, you have to convert it into numeric, and you have to treat it as numeric, and you have to perform that. But it is not that much efficient because if you handle like numeric, the order will not be retained. The order will not be retained. So you have to go for some other method, right? You have to write your own method. There is no such method, I think it is available. So you can handle like a numerical data, but that is not so efficient. The order will not be handled properly. So like you can find mode, then you can find mode. So whichever is having so which value has having highest frequency can be replaced. So that is one way you can handle.
Okay, ma'am. Thank you.
Yes.
Yeah, fine. Thank you.
Okay.
Thank you.
Okay.
Is there any other participant
Any
who have
questions?
some questions? No, I guess. Thank you, ma'am. Thank you all the participants for joining this session.
Sir, it is
Tomorrow
not
you
audible.
can.
Yeah. So thank you all. If you have any doubts, I'll be coming for the next sessions also. I'm ready to clarify your doubts. Thank you. Thank you all.
Thank you, ma'am. Thank you so much, ma'am. Thank you all the participants for joining this session. You can join again tomorrow by 4:30. We can have our next session tomorrow. Thank you so much. Now you guys can leave the meeting. Thank you so much.
Tomorrow 4:30 or 4, sir?
4:30, sir.
Okay, sir. Okay.
4:30 we will start. 4:30 we will start. Hello. Ma'am, today attendance.
Hello.
Today attendance is automatically taken.